All right, so the first lesson of logic, we're going to be talking about truth tables and using connectives within these truth tables. So, to start it off, all right, analyzing such statements and being able to understand what they really mean as opposed to what they are intended to mean is the purpose of mathematical logic. We're in this new unit here, okay, where we're pretty much looking at the structure of a mathematical sentence and then being able to determine whether or not it is a true statement or if it's a false statement. Okay? Now, a statement is a sentence or a phrase, and it must have a precise mathematical meaning. Okay? So this is, remember when we were talking about probability last year? I was like, take away all of those, oh, well, what if you flip a coin and it lands on its side? And we took out those types of situations. It's 365 days, not 366. We don't consider leap years, okay? We take out all those things. We only look at it mathematically, all right? Logic is the same way, okay? So when we're looking at a statement, we're trying to determine if it's true or if it's false. We need to look at mathematically if that's the case, not structurally English way, okay? Now, a statement is comprised of simple statements that either have a truth value of it being true or false, but not both. So when you're given the simple statements, it's either going to be true or it's going to be false. It's never going to be both. Okay? So these are just some kind of background things here for you when it comes to putting some of these mathematical statements together. Now, these statements that I'm referring to, these are literally like statements, okay? Like sentences, okay? Such as, I studied for my test and I went to the football game. That's an example of a statement, okay? It's actually a compound statement because it's two simple statements that are joined together with a connective. The connective that I used an example was and. I studied for my test and I went to the football game. Two simple statements connected together with a connective, which are the 5 that you see listed here, the 5 that are also on your foldable. Okay? Now, based off of these connectives, we can determine if your compound statement is indeed a true statement or if it's a false statement. Okay? But before we get a little bit deeper, I know some of you guys see that there are 2 ors, correct? Okay. Now, normally these ors are not, capitalized, like to distinguish the difference. They are literally just written as OR, lowercase. But you have to be able to distinguish between the 2. Okay? Or, there's 2 different versions. Okay? You don't necessarily have to write this down, but just kind of understand it. Look at these 2 sentences. You may study mathematics at higher level or standard level in the IB diploma program. Okay? Or, let's bring it down more towards Lake Wells. You can either study mathematics at the SL level or at the studies level. But you can't do both. Does everybody understand that? So that in that particular statement, that or basically means it's going to be one or the other, but not both. Versus the second sentence, it says you may study Spanish or French as a part of the IB diploma program. Granted, we do not have French at this school, but you actually could have done Spanish or French or both. Okay, if we had that option, one of them would have been counted as like an elective or something like that. All right, but does everybody understand like the differences between the 2 ors?
Yes.
Okay, one of them is an exclusive or. Exclusive means it is either one or the other, not both. Inclusive means it could be both.
That one.
Yes.
Yeah, but then isn't that taking account to background knowledge and like based off of the text and the context clues? Because the sentences are both the same. Because it says, you may, for someone who doesn't know that you could take both math classes at the high school, they might just assume that, that could also be inclusive. Because you could take both.
You can't.
Right. Well, we know that, but they don't.
Who's they?
Anybody
a non-IB student, they wouldn't be dealing with logic.
Right, but, I'm talking about, anybody else who's, but, then again, you can't take Spanish and French. You can't take Spanish.
Actually, you can't take both.
Right, but not in this school.
Because we don't have French.
Right, but there wouldn't be enough space.
I guess what you're saying is what happens if you don't know the background.
It'll be something. Yeah. It'll be something mathematically based. Okay. So something like
2 plus.
Yeah, something like if x squared equals x squared equals 1 and x equals negative 1 or something like that. It'll be something like mathematically based.
Because math is like universal. This is like all like
IB.
yeah, just like kind of like examples that we have. And just never mind.
Okay.
I'll get it.
All right, so let's talk about these 5 connectives. You have not, okay? Not is negation, okay? So that means you're basically taking a sentence and you're making it negative. There is a symbol that goes along with this, and that is this symbol here, okay? It's a horizontal line followed by a vertical line, and that would be, that stands for negation. I just put down the other side of the flap to have the symbol and the word associated with it, okay? If you want to have negation, conjunction, all that with it, that's fine too. All right? Then you have and. And stands for conjunction, okay? It's where you're basically putting two together, and that represents this symbol here. The first or, which is inclusive disjunction. Remember, inclusive is one or the other or both. That is a B. And then you have exclusive disjunction, which remember that means one or the other, but not both. And these are supposed to be horizontal. That's supposed to be a horizontal line.
How'd you mind diagonal?
And then the last one is implication. If ... then it is an arrow, a double bar arrow. All right, so truth tables. This is where you'll see these symbols come in, and this is where you're going to compare these simple statements, okay? As you know, mathematicians, we use symbols compared to words. And when you're looking at some of these simple statements, they will be labeled Q, P, or R. Those are usually the most common variables that are used to describe these simple statements, okay? Or to represent these simple statements. They're also combined with these different connective symbols to form compound statements. So you'll see things like this, or you'll see things like this, okay? These right here represent these compound statements. Simple statement P, this particular connective, simple statement Q, okay? But it does represent actual words to form a full sentence, okay? And as I mentioned before, each of these simple statements, P, Q, and R, they're either going to be true or they're going to be false, okay? Just a little background before we actually look at these truth tables with the connectives. Negation, starting with the first one. Okay, if you flip it open, negation of a statement P is written with this symbol. So when you see this combination together, this basically means not P, negation of P, okay? The relation between any statement P and its negation is shown in the following truth table. When you open up the flap, you'll see a Venn diagram on one side, you'll see a truth table on the other side, right? The truth table is already partly filled in, correct?
Yes.
Okay. So if you have a simple statement, there's only two truth values that are possible. It's either going to be a true statement or it's going to be a false statement. So the negation of that statement is going to change the truth value of the original simple statement. So if I negate this first one, it's going to end up being what?
False.
False. And then if I negate the second one, it's going to be true. True. Okay? It is impossible for a negation to be, like a negation and a simple statement to be true at the same time. It's impossible. Okay? Questions on that? That one's usually the simple one. So far, so good? Okay. So, for example, you may use the land for residential purpose. That is a simple statement. So the negation of that would be you may not use the land for residential purpose. Okay? Sometimes it will ask you to actually, you may not.
We have like a double.
Okay? Oh, well, we can fix that. It may ask you to actually write this out in words, what it actually means, and so then you actually just add in the word not. And I did copy it with the wrong Venn diagram, so if you guys could correct that, it's pretty light. You can just write over it. But negation would be correspondent to the complement if we looked at sets theory. And logic does go with the set and probability topic. So sometimes you'll have a set question. Within a set question, it'll be like a logic question as like a part C or something like that. The next connective is and. The conjunction of any two statements is written as P upside down V Q. That stands for P and Q. The compound statement is defined by the following truth table that we're actually going to go over, okay? Remember, that stands for and. And would technically represent the intersection when we're looking at set theory, okay? The general makeup, which should already be on your foldable, is this. Is this already on your foldable?
Yeah.
Okay. This is, a lot of times I'll always give you P and Q, okay? So it's more of a matter of can you do the actual connective, can you actually complete the rest of the table, okay? The only time the conjunction is going to be true is if both the two simple statements are true. Any other time it's going to be false. So true, false, false, false. The only way that the actual compound statement with the and is going to be true is if both simple statements are true. Any other time it is false.
Wait, but like for false false, wouldn't like a double negative just
Not with the conjunction. With the first or, the one that's represented by, we're going to do this example real quick. All right, so we're going to let P represent it is at least 35 degrees Celsius today, and we're going to let Q represent it is Friday. What does P symbol Q represent? How would you say that in words?
it is Friday and at least 35 degrees Celsius.
Close, not quite. Order does matter. Yes, order does matter. It is at least 35 degrees Celsius and it is Friday. Order does matter. Order does matter. So what does that represent? You're actually going to write that out. They'll tell you what each piece represents, and they'll ask you to write in the words. Sometimes they'll give you the actual compound sentence, and you'll have to write it in symbols. So you'll need to know which symbol means and then, of course, the order. Let's look at this one. It's not in your foldable, but it's just another practice. Let P represent, Dana got a 7 in HL Mathematics, and let Q represent Yuri got a 5 in HL Mathematics. What does that represent? Okay, so let's say it all together confidently, loudly for the video.
Dana got a 7 in HL Mathematics and Yuri got a 5 in HL Mathematics.
Very good. Okay? Let's use that exact same sentence and let's look at this particular compound statement. Okay? How would you represent what I've circled in red using the example with Dana and Yuri? Write it out in words. Who wants to, let me get one person, volunteer. Sorry.
Dana did not get a 7 in HL Mathematics, while Yuri did get a 5 in HL Mathematics.
Close. You're missing something very important.
Wait, it's not that, right?
It's an and. You've got to use the connective. You said while Yuri got a whatever. You got to say the word and. That's what that symbol represents, and that's where those marks are going to come in. Do you know what the symbol is? Do you have the correct order? Are you able to recognize that? So you would get correct order in using the not, but you wouldn't have gotten the ones you didn't write the word and. Does that make sense? So Dana got a 7 in HL Mathematics. Dana did not get a 7 in HL Mathematics, and Yuri got a 5 in HL Mathematics. What about the second one?
Dana got a 7 in HL mathematics, and Yuri did not get a 5 in HL.
Very good. Question. All right. Now let's look at the ors. The first one is the inclusive or, the one without the bar. Okay? The truth table. For this one. Okay, remember, this is the one is true if either P or Q or possibly both are true. So this basically says that if one of them is true, one of the simple statements is true, then the compound is going to be true. So if they're both true, it's true. If the first one's true, it's true. If the second one's true, it's true. But if they're both false, then the inclusive or is going to be false. Okay? For the inclusive or, which basically represents that one could be true, the other could be true, or both of them could be true at the same time, will only provide you with a true compound sentence. And when you are doing this one in words, it is important that you distinguish between both or not both. Okay, especially since there's two different ors here. This particular one says it includes one or the other or both. That one actually represents the union when you're looking at it in set theory notation. Okay? Remember, this is the inclusive or, the one without the bar. Questions? All right, the next one. Oh, example. Duh. All right, let P represent Dana got a 7 in HL mathematics, and let Q represent Yuri got a 5 in HL mathematics. I want you to write it out first, and then I will ask you what you all say. What does this represent? Don't say it out loud. Write it first. All right. So, since this right here is the connective or, you need to definitely have P on the left side of the or and then Q on the right side of the or. But because it's the inclusive, what other word did you need to include? Both. So, Dana got a 7 in HL mathematics, or Yuri got a 5 in HL mathematics, or both. You're overthinking it, okay? Take it back all the way to this one. P or Q or both, okay?
Oh my god.
So that's it. So. Okay, when you start trying to add, you don't definitely want to add an and, okay? Especially since that's one of the connectives, and that's not the connective for that particular symbol, okay? But then, just follow that right there. Whatever P is, or whatever Q is, and then of course, or both, because this is the inclusive. All right? Kind of like a chi-square, right? Blank is independent of blank. Isn't it? All right. Exclusive disjunction. That is kind of correspondent with what is it? A complement intersection B complement. Okay. That's what it looks like on the Venn diagram. All right. There we go. So we exclude the possibility that both simple statements can be true simultaneously. All right, so true, false, false, true, false, true, false. Okay? So the exclusive disjunction, we exclude any possibility that both statements could be true simultaneously. So that means that this one is false, because they cannot be both true at the same time. However, one could be true at the and the other could be false. So that makes the exclusive disjunction true. That makes this one true as well. And two falses will also be false as well.
This is the exclusive.
This is the exclusive. So when we're trying to write these sentences out, we would say blah 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 or blah blah blah, but not but not both or neither. No.
No, but
Yeah.
not or both. No, but neither.
But not both. But not both. You would say but not both.
Or not.
But not.
But not both.
But not.
Because
Right.
Okay? So, if you look at the first one, the penalty for those found guilty of murder is death or life imprisonment. Why is this exclusive for?
You can't do both.
Because you can't do both, okay? Either death or life in prison. They don't do both. Granted, yes, if you have life in prison, you are going to die, okay? Because you're still in prison, but it's either death, execution, or imprisonment. So that is why it's an example of exclusive for. Look at these two statements down there as well. What's the difference? The penalty of those found guilty of speeding is a $500 fine or 3 months in prison, but not both. The penalty of those found guilty of speeding is a $500 fine or 3 months in prison.
top one is
Which the second one means it could be both, which means it would be
exclusive.
inclusive.
I'm dumb.
So there's a big difference. So if you guys were to say this was a P and Q type of situation, you had to write down words. There's a big difference between the two. This is if it had this symbol versus this symbol. Okay?
So for the inclusive, you don't have to say or both.
For the inclusive,
Oh yeah.
you can, but I would include it just to be safe.
All right.
I'll include it just to be safe. All right. Questions on these four connectors to start. All right. We're going to do the last one tomorrow because that's in a whole nother field. All right. So go ahead and flip to page 87. Any additional notes you want to take? There is going to be 2 examples, I think, of truth tables that I do want you to add to page 87. So, that's pretty much what you use that page for, and any other additional notes, like I said. So in logic, you must be careful to deduce only what is necessarily true from the statements. And like I said, the best way to do this is a truth table. That way it's clean cut and dry. Okay? We're going to construct the truth table for this statement right here, which basically stands for I am not studying French and I am not studying Chinese. Okay? We are going to fill in what P represents and what Q represents, and then we're going to construct the truth table for this compound statement right here. All right, here we go. So, like I said, we're going to construct the truth table. Okay, it's very rare that you're going to actually end up constructing a table like from scratch. They usually start off with you with your P's and Q's to make sure that, the key and the mark scheme all look the same with your paper. So, what does P represent?
Studying French.
Careful. I am studying French. So remember, it's just P, not P. So then Q would be I am studying Chinese.
We have to have the I am.
Out. Make a conjunction.
Okay? So now we're going to form the truth table for this compound sentence right here, which basically says I am not studying French and I am not studying Chinese. We're going to need a couple of things within our truth table. We're going to need P's truth value, of course. We're going to need Q's truth value, of course. All right? Now, if you think about that compound statement, what else are we going to need? We're going to need not P and not Q. So then, once we have those two, we'll be able to compare them with the conjunction. Not P and not Q. Okay? Everyone should start their truth table off the same way. Make P true, true, false, false. Make Q true, false, true, false. If you have to ever create your own, this is the easiest way. Putting that way when I do it. What looks like that?
Like right next to the P.
This is not.
Is it always gonna be like set up like T T T F F T?
Yes. The P and the Q should always be the same. Alright? So, you want to fill in column by column. A lot of times how this is graded by column. So if you miss any entry in the column, it's wrong. Okay? But there is potential for follow through if you follow through correctly with the incorrect columns. Okay? So, not P. That means we're going to negate the P column. What's the opposite of true?
False.
What's the opposite of true?
False.
What's the opposite of false?
True.
What's the opposite of false? We're negating P. We are negating P. Now we're going to negate Q. What's the opposite of true?
False.
What's the opposite of false?
True.
What's the opposite of true?
False.
What's the opposite of false?
True.
There we go. Once we've done that, we're no longer going to look at the red T's and F's. We're going to look at the blue ones, okay? And we're going to use those blue T's and F's to determine the conjunction, okay? So, if not P is false and not Q is false, then the conjunction of false and false is what? It's false,
False.
okay? Go back to your original conjunction, which was right
Only TT.
right here. If they're both false, then it's false. And I know this says, hey, well, this says P and Q. Those are more for just like placeholders. If both of them are false, then the conjunction is false. If one's false and one's true, it's still false. The only time it's going to be true is if both of those statements were originally true. Okay? So if I go forward some more, take that away, whatever that was. If it's false, then true, then the conjunction is what?
False.
If it's true, then false, then the conjunction is
False.
If it's true, then the conjunction is
True.
and that is the truth table for that particular sentence. Questions? We're going to now construct the truth table for this statement here. Okay? Still using the same P and the same Q from the last example, except this time we're doing this particular statement which says, I am not studying French. I'm not studying either French or Chinese. So it's the or, which would be one or the other or both, but it's the negation of that. So I'm studying neither French nor Chinese. Studying something else. Spanish. What y'all studying?
So wouldn't all of them be false? Because you're not studying right.
Mm-mm.
Wait, be true because you're not.
You gotta look at the truth table. You gotta look at the truth value of P or Q, and then you gotta negate whatever that is. So we always gonna start off with P and Q or whatever the variables are. We're gonna need 2 more columns. What's gonna go in this the third column?
It's like a little.
Is that an and symbol?
Oh, no.
It's the not symbol,
Not.
right?
Wait, so. P.
Not studying.
That's an inclusive.
Yeah.
It's the inclusive one, that's correct.
Oh,
You're gonna need P or Q, and then you'll need
not.
the negation of it. Like you gotta build it piece by piece.
I get it.
You guys wanna try this on your own? Okay. Yeah, same trial only. And just to make sure we're all the same. TTFF for P, TF for Q. So we all can be the same. So you're filling in those two columns. Let's see how you did. It's the inclusive or, which basically says that either one's true, the other one's true, or they both can be true. So, true means what? True. True, false.
True.
False, true.
True.
False.
False.
Very good. That is the inclusive or using it straight from the table. So now the final answer to determine the truth table for this compound statement is just the negation of the blue. What's it going to be?
False. 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 True.
Very good. Questions? Okay. Look at the two truth tables that you've constructed. Do you notice anything? Those two statements are the same. They have the same truth value, right? So those two statements are said to be logically equivalent. Okay? The symbol for equivalence. What you see there? Okay? So it could ask you, it could make you do these two different truth tables, and then you have to determine, okay, are these equivalent? Or they might not even make you do the table, but it might ask you, determine if it's equivalent, justify, or something to show the truth table. Okay? And then show how the last column for both of those two statements, those two compound statements, are the exact same. This is the last one that's down at the bottom, but are there any questions before we get to that bottom one? But I definitely got to go over this one because this is the one that students say, oh, when they see parentheses, they think, oh, let me distribute the not symbol to both. Okay, so they think that, that once they see something like this, oh, I can distribute the not, and it can be not P or not Q. Okay, we're about to do the truth table for that statement down there at the bottom.
Why doesn't it work like that? It's the same thing. I guess it's distributed. Now it's like not P and then not Q.
Well, let's look at the truth table. Let's look. I'm going to need 5 things here. What are my 5 things? P, of course. Q, yes.
Not P.
Not P.
Not Q.
Not Q.
Oh, not P. Inclusive or Q. I mean not Q.
There you go. All right, I want you to complete the truth table for this. Complete the truth table for this. Oh, you ain't even seen them yet, boy.
What?
They get bigger.
That's one bottom. That's why our name says like here. Bro, I drew the bird.
And then the opposite of Q. True.
Dubois.
Whatever. And then
Remember that movie? There's a movie.
use these two
Oh, Mario, I know
to
you wrote
determine
that
the
one.
last one.
That was probably actually I did.
So it has to at least have one true.
Okay. All right, so we have true, false, then true, false. Okay?
Okay, this is what you're.
So, not P. It should have been what?
False.
False, true. Not Q.
False.
True.
Okay? So now we have to take what's in blue and we have to do the inclusive or. Not P or not Q, which also means or both. So, false, true. True, false. True. If you look at the truth table between this and this one, are they the same?
They're opposites.
No, they're not the same, which means that you cannot distribute over the negation sign and say that they mean the same thing. So the parentheses are going to make a difference, okay? So these two that I've circled in orange, they are not equivalent, okay? However, what's in the full orange sentence, that is equivalent, okay? Yes?
Okay, so for the P and Q in the beginning, I get it because that's what you start off with.
Mhm.
But then after that, like, it doesn't make any sense. Like, how are you getting false out of it too?
Because remember, this right here means it's not P. So you have to do the negation of this P column. So you have to negate this entire column. So that's why true turned to false, and then false turned to true there. Remember, this symbol means negation, so you have to do that first. You have to do each individual piece before you can actually connect them together.
That makes sense, yeah. But then how do you get the orange?
Okay, so then once you've gotten the two blue columns,
Yeah.
then you use those two blue columns to determine what is that last column. Okay, because those are the two that we're trying to compare. So we're using with that particular connective just what's in the blue. So when it's false and false and it's the inclusive or, that means it's going to be false. If we go back to the inclusive or, which is right here, when they're both false, then it's going to be false.
Right.
But any other time, if one of them is true, at least one of them is true, then it's going to be true.
Okay.
So then that's exactly what we use, and that's what we look at to answer that last one.
I feel like this is like very similar to sets. It's just words and
Exactly.
That makes sense.
Now, you do not have to memorize this. You don't have to memorize that, okay, when it's inclusive or and they're both false, it's like you don't have to memorize them. I did, just so I don't have to keep looking at my reference booklet, but it's all there. This is going to be what's in your reference booklet, okay? Now, if you choose to memorize it, hey, then that's fine. You do you, okay? But look, right here, they show you, okay, when you negate, you're literally flipping P. Does everybody see that? When it is the conjunction, the and symbol, okay, you're comparing P and Q together. Two truths make a true. True false is false. False true is false. False false is false. Okay? No, this is conjunction. This is this. Okay? So, and it doesn't matter what is on the left and the right hand side, okay? If it's true, then false, it's false. If it's false, then true, it's false. If you're looking at the conjunction. The table's lined up for you there, so you don't have to memorize it. But if you want to, then that's fine. That's on you. There you go. Okay?
It's only useful